Alright guys, welcome to part 2 of our lab, our motor generator lab. This first question is about rotations. So we have a series of gears that I'm going to actually look at, and we're calling it a base unit. And this device is something you would normally be building in class together, but it is comprised of 3 separate gears: a tiny gear, a medium gear, and a larger gear. And it's attached to this unit here. If you look inside, it's clear. So here's my gears. And this tiny little gear, which we're calling A, is attached to a rotor that when I spin, actually spins copper wire inside. Okay, so remember from the last lab, inside this device, we had copper wire that was spinning inside magnetic field, which we don't actually have in the base unit that we're looking at. Alright, so number 2, we're going to insert gear B into the center hole of this base unit. We're going to build this out, and we're going to try to line up these black marks that are on the gears, and actually they're kind of hard to see, so let's make them a little bit more obvious here. Alright, and make them on C. Alright, so we're going to spin gear B with our fingers 1 full rotation, and here's where you need to pay attention to the black lines. You want to count how many times the smaller gear A spins and record it. So there's 1, there's 2. Now you guys need to finish counting until I get this other black line all the way around. Okay? Alright, so let's see what happens when we insert gear C to this whole unit. So then we will have a series of gears. C is going to be a bit too loose to just attach on here, and it's not going to be quite as easy to spin it. So we're actually going to add a cover to it here. Alright, so let's line these gears up and attach this lid. Flip it on, stabilize it, and then we're going to add an arm. And the arm is going to allow me to spin gear C, which in turn will spin B, and then we'll turn A. So if you're forward thinking, you're going to be thinking about the ratio here of spins, but the question is, count the number of rotations gear A makes and record the number in the table below. Alright, so we're lined up and we're going to start spinning. Alright, unfortunately it looks like the light is reflecting directly on A, so you can't actually see. But as we continue to spin and we bring C all the way back to its original place, there would have been 25 rotations of gear A. For every 1 crank of C, B is going to spin 5 full rotations, and A is going to spin 25 full rotations. Maybe you can see it a little better now. Alright, so the question is, what effect does adding gears have on the rotation of the copper wire coil? So you can see as I spin gear C, and let me take this off to spin gear B, okay? But then if I add gear C back on, I always put this on wrong every time. There's B spinning. Let me add C. Add my arm. And you can see Look how fast that goes. So I want you to be discussing with your group what this actually does. Adding gears, what effect does adding gears have on the rotation of the copper wire coils? This is something you guys should discuss in your partnership, in your group. So pause me and sort your way through that. Right, so now for the most riveting part of the lab, you are going to count with me along the teeth of each of the gears. So here we go. My hand's in the way. There's 10. Okay, so you should have your number for C, how many teeth there are in gear C. B is the same because it's the same size. So the question is, what's the ratio and how does that relate to the number of rotations? Right, so we're moving on to generators, and from part 1, you notice that gear A was connected to the rotational arm that had copper wire wrapped around it. And so from our last lab, we looked at a motor generator, and in here we actually have the exact same thing, but we didn't have a magnetic field. So here we're adding a magnetic field, and this is part B here. We've added the red and blue magnets, and the question is, what happens when you spin the copper wire within that magnetic field? That should feel like review from last time. All right, so current, we're gonna move on to current, and we're going to actually attach these alligator clips. That's the noise I think they make. Okay. So we're going to attach these alligator clips to the nodes on the other side of this device here, and we're going to hook the base unit up to a light bulb to create a circuit. Okay, so let's hook these on. And we're not going to use the other gears yet. So here's my ammeter. This is measuring my amps. So I can actually spin it and see what it registers as. We're going to use the 500 amp measurement. So we need to attach both sides to it here. All right, let's see if I spin, get it in view. And so we're going to read the top lines there, which is 0, 100, 200, 300, 400, 500. So if I'm spinning my A, can like kind of get it like just maybe up to 30, 35, I would say on average around 25 amps. And if I add gear B, here, if I add another gear, remember what happens to the rotations here, and I spin it, I can actually get my amps all the way up to as high as 100, 150, kind of topped out at 150 there. Now, you can imagine if I add gear C, so for every gear that I'm adding, I'm going to be increasing the rotational spin of the original gear that's attached to the shaft, that's attached to the copper wire that's inside a magnetic field. Here, I'll add my arm to C, and we spin it, and, oops, wrong way, and there we go. I can actually top it out at 500. It's technically microamps. I can top it out there, so 500. All right, so that's a pretty big difference between them. So this is the way I'm reading it. I see that my first gear only went up to about 25, gear B went to about 150, and gear C went all the way to the 500 microamps. All right. All right, so let's see what happens when we add a light bulb. So we've got my light bulb holder, our alligator clips. We're gonna attach it to the nodes, and I'm gonna add a light bulb. I love these little light bulbs. All right, so let's add gear A to the light bulb. So if I just spin gear A, what happens? Okay, how about gear A and B with the light bulb? Okay, gear A, B, and C to the light bulb. Add my unit. Ah, amazing!